So now that you know something about the structure and functionality of StampedLock, let's go ahead and take a more detailed tour through its key methods. First, we'll start out with writing mode methods, which acquire the lock exclusively. So you should be familiar with the concept of exclusive locking. That's what we get with the writer mode or the writer mechanism with Java reentrant read-write lock, as well as what we always get with reentrant lock and Java synchronized methods and statements. As I've mentioned a number of times before, writer mode is pessimistic. It assumes that there will be contention and is prepared for it. So the way that these methods work, you can see there are three of them. They all return something called a stamp, which is a long that is encoded to contain a version and an indication of the mode. And the version is basically something that is incremented so you can tell one call of a lock that's been acquired for writing from another one. So you can think of it basically as a sort of a universally unique ID, if you will, with different variants. The write lock method will acquire the lock exclusively, blocking until it's available for exclusive access. And this particular method cannot be interrupted. There's also a write lock interruptibly method that can be interrupted, very much similar to what you'd see with Java reentrant lock, where you've got two different semantics, one that can be interrupted, one that can't. There's also a try write lock method that will acquire the lock exclusively if it's available at that moment. Otherwise, it returns 0 and says, sorry, boss, can't actually get the lock with exclusive mode at this point. You'll have to try something else. And then there's also a timed version of try write lock, which will return with the exclusive lock if it's available within that time frame and otherwise returns 0. This method, interestingly enough, throws interrupted exception if it's interrupted. So it is possible to interrupt this particular method. So that's writing mode. Now let's go ahead and take a look at the key methods that are in the reading mode of StampedLock. As we've talked about before, the read mode methods can all be used to acquire the lock non-exclusively in a shared way. So multiple threads at a time can acquire the reading mode, and then they can all read at the same time. Once again, this is a pessimistic lock. It assumes that contention can occur and has the mechanisms to deal with that. Once again, also, each of these methods returns a stamp, which is a long that indicates the version number and also the mode, namely it's in read mode. Read lock acquires the lock non-exclusively, blocking until it's available and cannot be interrupted. There's a read lock interruptible method that can be interrupted. Try read lock will try to get the lock in reading mode, returning right away if it can, or otherwise returning 0. And no surprise here, there's also a timed version that behaves the same way that the timed writer lock mechanism worked, except this time it's trying to get a reader lock. And it can also be interrupted. Okay, now let's talk about something completely different. To quote Monty Python, let's talk about stamped locks and their optimistic mode. So the optimistic reading mode acquires the lock non-exclusively, but also probabilistically. And as with regular read mode, you can acquire a lock and have many threads acquire it in optimistic mode at the same time. Unlike reading and writing mode, which are basically pessimistic, the optimistic read mode is, as the name suggests, optimistic, which means that contention is assumed not to occur. Now, that, of course, raises the question, well, what happens if contention does occur? And that's exactly how you have to use these locks. So let's first look at the try optimistic read method. This returns a so-called observation stamp that will then be available for later validation. Or if the lock is currently held exclusively, it will return 0. It'll say, sorry, can't get you an optimistic read lock. So this code that uses this mode will end up reading the value of the fields that occur after we do the try optimistic read, and then store them into local variables, but only allow them to be used, by convention, of course, if they turn out to be validated. Well, what the heck does it mean to be validated? And we'll see what that means in a second when we talk about the validate method. Internally, try optimistic read does a volatile read on a field inside of StampedLock to ensure that they're fresh values of the fields. So when we call try optimistic read, it doesn't acquire a lock, but it does do a volatile read, which then goes ahead and updates the caches. Remember, you can have a multi-core processor with shared values that are cached in processor cores. And so when you do a try optimistic read, you're going to end up getting the fresh value of any fields you read. But as we'll see, those may not be fresh for long. The other method that's part of this protocol is called validate. And validate returns Boolean, and it will return true if the lock has not been acquired exclusively since try optimistic read issued the optimistic read stamp. So if nothing has changed, if there's not been a successful write lock acquisition between the point where try optimistic read was called and where validate is called, validate returns true and everything's fine because nothing was changed. However, if it returns false, that means that there was a lock that was acquired for exclusive access, which means the values of those fields that we just read are probably nonsensical. So you shouldn't depend on them. So if it succeeds and returns true, there's really, really low synchronization overhead, basically just that read of a volatile when try optimistic read was called to get the fresh values. And in the case that validate succeeds, there's no need to unlock the lock because there was never a lock acquired in the first place. So we'll come back and take a look at optimistic reading when we look at the example in more detail, and you'll see that it's very cool, somewhat convoluted, and works really well under certain conditions, but under other conditions, it doesn't work very well at all and actually may make your code slower. So you know what they always say, an optimist can never be pleasantly surprised. Well, you can have some unpleasant surprises by using optimistic mode if you're not careful. Let's now talk about conversions. And conversions are these three methods that can be used to conditionally convert a stamp that was acquired with potentially one mode into other locking modes. And despite the lack of documentation, which is sad, they all work atomically. So the conversion that takes place is an atomic conversion. And I actually had to go back to Doug Lee, who wrote the class, and ask him the semantics a couple of years ago because somebody had asked me. And he, in fact, assured me and confirmed that these are all atomic operations. And I think he was also going to ask the people at Oracle to update the documentation to make that more clear. Let's start by talking about try to convert to write lock. This is a method that will try to conditionally convert some stamp, which could be a writer stamp, it could be a reader stamp, it could be an optimistic read stamp. It'll try to convert it to a write lock. So if it turns out it's already a write lock, then we're fine. So it just returns and no changes were required at all. If it represents a read lock and it turns out that nobody else is holding the write lock, then it will atomically release the read lock and return a write stamp. So it'll upgrade it very quickly and atomically. This is what's called a lock upgrade. So you can upgrade from a read lock to a write lock. Recall that reentrant reader writer lock only supported downgrades from writer locks to reader locks. If the stamp represents a read and it's an optimistic read, then return a write stamp if there's one available immediately. Otherwise, if it's basically not available immediately, then you return 0, indicating we weren't able to do that atomic conversion. Let's now talk about try to convert to read lock. So this will check the stamp that's passed as a parameter and perform an action. If it's a write lock, then it will atomically release the write lock and read it, put it in read mode. That's a lock downgrade operation. If it holds a read lock, then we're already a read lock, so we're done. And if it returns an optimistic read, return a read stamp only if there's one available. Like, in other words, somebody doesn't hold the lock for writing. Otherwise, return 0. If we cannot convert it to a read lock right away, it says, sorry, Charlie, couldn't do it. And then the final method is try to convert to optimistic read, which will conditionally convert a stamp to an optimistic read lock. So once again, the stamp parameters examined. If it's a if it's holding a lock, release it and return an observation stamp. This is another downgrade operation. If the stamp represents an optimistic read, return it if it's validated, so it does implicit validation. Otherwise, return 0. So it's obviously easier to convert to optimistic read because that has the least powerful semantics. There's also some methods that are used for unlocking stamped lock. So there's more of them than normal. And there's several ways to do it. As you can see, there are 3 methods for unlocking a stamped lock. Unlock write lock will release an exclusive lock if it's a write lock. Obviously, if it's a read lock, it'll fail. Unlock read will basically unlock a read lock if it's a read lock. And if we don't know if we have a read lock or a write lock, just use unlock, and then that will go ahead and either unlock the write lock or unlock the read lock, depending on which one it is. So it's actually slightly less efficient than unlock write and unlock read, but there are conditions under which you need to know, or in which case you don't know which one it is, and we'll talk about that, having to do with doing these conversion operations to upgrade and downgrade locks. So unlock is the more general way of doing things, which can be useful in practice when you don't want to keep track of that information externally. So that's the end of the overview of the key methods in Java StampedLock. I think you'll agree with me that there's a lot more of them than there are with the Java reentrant read-write lock, which is one reason why it's more complicated to program, but as we'll see, it's also way more efficient.